welcome back to Learning Lockdown, and as you can probably tell, it's now time for some science. So we've got Professor Vittenbavi with us today. Professor, what are you going to tell us about today? Professor? Not again. Which one was it?
Hello there, hello and welcome to Learning Lockdown, and it obviously is time for science with me. Now, Mr. S, what have we got coming up today?
You tell us.
Why?
Because you know, you're the scientist, not me.
Am I?
Yes.
Oh, I thought I was a veterinarian.
No, you're not a vegetarian, you're a scientist.
Okie dokie. Well, today we are carrying on our topic on forces. Now, last week I got you to go and have a look at push and pull forces. Particularly, those are contact forces. And today we're going to carry on with that theme of contact forces and look at one called friction. Now, friction, you actually get a variety of types of friction. We commonly think about it when we think of hard, solid surfaces. When two things come into contact as a solid and they try and move against one another, then you get friction. But actually, air resistance and water resistance are also types of friction, because you've got air and, let's say, a plane coming into contact with one another. That's two surfaces and they generate friction. We just give it a special name, air resistance. And water resistance, when you've got a boat and water, they come into contact, you generate water resistance, which is another type of friction. But I'm not asking you today to fly a plane or take a boat out. No. Travel restrictions do not let you do that. So what I want you to do today is to test friction on surfaces around your house. So, what you need to do is find a nice heavy object. I have got this. This is actually very light. But this is the object I'm going for. This is just a nice, solid object that I can use. It's not going to break when I'm testing with it, and it's a good object to test with. Now, I am going to place this on a number of different surfaces to see how it moves. But first of all, I'm going to make a prediction. Because what I've done with my surfaces, I've grouped them from smooth to rough. So these are the three surfaces I have chosen, but if you've got other ones at home, use as many surfaces as you can. I have got a piece of metal, and it's a very smooth piece of metal. I have got this surface, which is a tea towel, so it's soft, but I'm looking at texture. It's not smooth, it's probably a little bit more rough. And I've got a piece of wood. Now again, this is quite smooth. It was one of my floorboards, but now I've just left a hole there. Okay? Now I've grouped them from smooth to rough. I've said the metal is the smoothest and the tea towel is the roughest, with the wood somewhere in between. And I'm going to make a prediction, because I want this block to move over the surfaces. And I want to think, well, which one will it move more easily over, and which one will it be trickier for it to move? You see, if an object is finding it hard to move over a surface, if it's trickier for it to move, that is because there is more friction being generated between the bottom of the object and the top of the surface it is moving on. If it finds it really easy to move, so that means less friction is being generated between the bottom of the object and the top of the surface you are testing it on. So my prediction is that it will be easier for the object to move over my smoothest material, which is my metal. I think it will move really easy, and I think it will be more difficult for it to move over the rough surface, which is my tea towel. That's my prediction. I haven't tested it yet. So, how are we going to test it? Well, if I was in my laboratory or you were in school, your teachers might go and get a Newton meter or a force meter, which tests how much force is being put onto an object. But I doubt many of you have got one of those at home. If you do, you could use that. So we're going to try and use things you might have around the home. So I'm going to need to clear a bit of the workspace here. Okay, so I've got my three materials. I've got my object. My object must remain the same at all times. And I've got one more thing. Now, I've used a whiteboard for this, but I would recommend for yourself you would need a piece of cardboard or paper to draw this on. And if you don't have something called a protractor, then you can click on the link down below and you'll get a protractor on your computer screen, which you could trace. Now, a protractor, this is a very large model of one, tests the angle of an object. Now, let's just show you with my ruler. If my ruler was flat, that would show it is tilted at 0 degrees. Oh, that's cold, very cold. Not that kind of degrees. Degrees of angle. So, if it was a 0, it would be lying flat. And the steeper, now you'll spot this point here, this is my pivot point. So this part of the ruler will never leave the ground. As my ruler begins to tilt, you'll see it lines up with some of these numbers on this scale. These are a bit like the circular scales you've been looking at in maths. So as it gets steeper and steeper, you'll see the angle in degrees gets higher. This is 45 degrees. As it goes all the way up until it's vertical, it would be at 90 degrees. And we're going to use this to test friction. So, Mr. S, can I ask you please to very carefully hold that next to my board. All I am going to do is test when this object begins to slide. You see, I'm going to let gravity help me. I want gravity to let this object slide downwards. But if it's flat at 0 degrees, we know that's not going to slide off our object. So what I'm going to do very slowly, and we're going to watch together, me and Mr. S, we're going to lift the end of my board, keeping the pivot points the same, and we're going to watch until the very moment it begins to slide. You might want to race it down your materials to see how long it takes to slide down, but I'm just looking to see when it begins to slide, because that means the friction has given up and it is starting to move. So, let's have a look. 0, 10, halfway 15, 2. Ooh, I would say that's not quite 20 degrees, but it was past 15, I'd say roughly 18 degrees. So, my wood moved at 18 degrees. Let's write that down. Okay, that's wood. Now you might say, how are you going to test the tea towel? Well, I'm going to be a bit sneaky and use my piece of wood to help me. I can lay my tea towel nice and tight over the wood, like so. And now the surface is now in contact with the tea towel. It's no longer in contact with the wood, so I can still test. So that's nice and flat. We're at 0 degrees. Off we go. 0, 10, 15, 20. Remember with the moment it moves. 25. Oh. I would say that's just past 25 and not yet at 30. That's around about roughly equal to 28 degrees. So it had to go much steeper before that started to move. So it was harder for that block to move because it allowed it to get much steeper. Finally, I'll try my metal.
Now remind us of your prediction here.
My prediction was that the rougher object would generate more friction, so it would be harder for the block to move. Now clearly that's true because it took the steepness of the ramp to get to 28 degrees until it moved. So it was really gripping onto that block. My prediction was that the metal would be easier, generate less friction. So if my prediction is correct, then my block should begin to slide at less than 18 degrees. Whew, we will see. 0, 5, 10. Oh! Not even 15 degrees. I would say it was around about roughly equal to 12 degrees. So the metal was 12 degrees. So my prediction was correct. The smoothest surface, which was my metal, generated less friction, so the block moved more easily. Now for you, your metal might not be as smooth. You might have a rough piece of metal, and you might have more materials than what I had available here. But what I would like you to do is go and test what surfaces generate less friction or more friction. Do you find the same pattern as me, that the smoother ones generate less and the rougher ones generate more? Let me know. Also, we've attached a little task all about testing the surface for rolling a car on. So if you want to push your investigation further, you can go and try that. That is all for Science this week. I will see you next week. Wittenberge!
Thank you, Professor Wittenberge.
No bye.
See ya.